Great. Before we start, everybody, a quick note. Just please mute yourself and put the questions by in the chat box. With that being said, thank you for joining. This is Chapter 6 of AI Talks by Sedin Technology. Today with us, we have Ansuman. He's currently working with Deloitte as a principal solution engineer with over 15 years plus experience. He is also has experience into AI, Gen AI, and he has been forefront of building intelligent system in the real world challenges. His expertise span across Microsoft Azure AI enterprise solutions and general in the AI landscape. Today, he'll be speaking with us about LLMs, Langfuse, and future of intelligence system. With that being said, Ansuman, I'll hand over the webinar with you.
Sure. Thank you so much. Thank you, Sonia. First of all, thanks to Sedin Technologies as well as Sonia for extending this invite so that to share what we are learning. So without further ado, maybe we can get started. Uh, Let me share my screen and let me know once you're able to see it.
Yep, we're able to see.
Yeah, cool. So yeah, my name is Ansuman Satapathy. I currently work as a principal software engineer in Deloitte. I'm based out of Hyderabad. Currently, the use cases or the work that I do is more around Gen AI. So when we say Gen AI, it's about uh, maybe like synthetic data generation, about building deterministic systems, evaluating LLM responses, and all those things. So as we know, as much as AI is helping us, it's critical to understand and evaluate what we are using from it to get actual value. So hence saying that, so the topic that I have kind of volunteered to do is like demystifying AI, LLM Langfuse, and the future of intelligence systems. Uh, the reason I picked up, just a second. Yeah, sorry. Yeah. So the agenda today is that small intro, so that's done. But we will start with something called as that why we need observability. What do we mean by observability? We normally use observability in normal software engineering applications as well, right? We look at the logs, or we look at the calls, we look at the traces, and we figure out why it failed, how it failed, and how we can fix it. So nothing different here. It's just from the lens of an LLM, cause it's a little bit different, a non-deterministic system. So what all things and what all tools we can use to figure that one out? What are the concepts that Langfuse uses to do that? Then we'll go through two demos, one simple and one a little bit more elaborate, followed by Q&A and then the closing comments. So before we start in, like this is just an open question and I want it like to be a session. Like if the microphone is also on, you can say in or you can type in. So when you see these devices in front of you, what does come to your mind? Like what are they used for? What are these instruments? Like could you give it a try, folks on the call?
Stopwatch.
Right, right. The first is stopwatch. So
Measure. Measure.
measuring. Perfect. So yeah, so that's the intention. The idea is that if you want to observe, like if you want to observe certain things, right, the first and foremost thing is you need to measure it. So without measuring, you will not be able to observe it in a longer period of time and then understand how the patterns change over a given period of time, right? And hence just getting a real world examples, like we have stopwatch and speedometer and ammeter and all these, so many tools we have with us which help us measure and observe the movement and control flows of things. So same here as well. uh, uh, and we picked up why observability. So the reason we pick observability is so important and specifically so critical now when we are using LLMs is that it would give insights on what is happening under the hood, right? Because as we know, LLM mostly, like if it is uh, an open source, then maybe you know what is happening, but more or less the commercial ones that we really tend up using, we do not know what happens under the hood or how it behaves. So we still do not know because that's how it is kept. But at least if we observe what is going in and coming out and try to figure out the last call right from the application and trace it out, it would help us make deterministic and more stable systems, right? So gone are the days where we used to really write code and calling specific APIs and making a very programmatical way of doing. Now, probably people have started adopting AI, maybe to generate data, maybe to solve a complex equation or whatever, right? But the output can falter, it might change. It's not deterministic, as we call it, stochastic, right? So there can be changes there. So still, how do you observe at it and then really take a look into it? So I so there are multiple tools here I've listed on the left hand side who do the same thing. So there is Helicon, there's Comet Biopic, there's Arise by Phoenix, and so on and so forth. There are multiple observability tools which have come into the market, and it's like every one of it is heavily used. You will find out someone definitely working on one or two of them. But the one I picked up, Langfuse, purely because at one point of time that was the most used as per their claims, as most used on GitHub, and they have good documentation and they have good support and a good roadmap. So and they have community hours, so you could definitely join their Discord server or their community hours and understand what new they're planning also. So it's interesting to see how they do that, right? And as for them, it's like the most downloaded OSS LLM ops across Python, JS, and Docker. So that's why I just included. But what are we going to learn today is not specific only to Langfuse. Yeah, there might be features specific to Langfuse, but the concepts and all mostly would remain the same as you pick up any tool to implement it. I'll take a pause. Any questions till now? Cool. So let's start with understanding what does Langfuse do and what are the building blocks. So basically, these are the data models of Langfuse. Okay, so first is traces. So if you see the diagram below, there is a fundamental model of how the data is collected and kept with systems like Langfuse, and it starts with a very basic definition of a trace. So trace is basically a single request or an operation, right, which happens over the while. So it can contain, like it would contain your total input, output, and even if there's some metadata onto like who's the user and what are the like is like what's the session ID, what are the associated tags of the user. So all these varying metadata that we can have along with the trace, so that defines trace as an object. And if you see on the left hand side the corner diagram, so you see that you have a trace, right? And trace can have multiple observations, right? So observation is then the next block that we have, and observations will have three things inside it. It would have events, spans, and generations. Events basically are just building blocks to track discrete events, like the you are calling the LLM, you are getting data from the LLM, right? You're doing some event kind of thing. So that kind of gets tracked under events. And spans are basically the duration of a unit of work in a trace. So suppose you are calling the LLM and getting a data after a second. So probably that 1 second would be a span. That's how we define it. Like it took a second for the LLM to respond. And generations are like additional attributes. For example, maybe you're using Anthropic, then your metadata will have, okay, you are using Claude model from Anthropic, or you're using Gemini from Google, or you're using OpenAI. So all these model related information and the prompt information also, they go into generations. Yeah, and one thing to note here is that the observations can be nested also. So one observation can have multiple observations inside it. uh, I'll move to the next block. Just a second. I just want to minimize this. Yeah, cool. Yeah, so building blocks. So the next is sessions. So once you once we start capturing the sessions, right, which is the single request, what can happen is that you can build a session which can have multiple traces inside it. So session can be probably you are looking at a workflow, maybe a user logs into the application and really adds something to the cart, or maybe a user logs into the application and transfers money, like any kind of event. So basically you take a session and you say, hey, this is the start point and my end point, and this is my session. And in between these sessions there can be multiple traces, because the data or your operations can flow back and forth, right, from you to the application to the LLM, and again back to you, right? So traces are grouped into sessions. And sessions are used to group traces that are part of the same user interaction. Example, like when you're chatting, a thread can be considered as a session. So that's what sessions help us basically if there are a lot of continuous activities doing the same thing, and you want to trace or you want to see it at maybe at a hierarchical level, you put them into a session and you look at the session object and then take your decision. And then the third building block, which is important, is scores. So traces and observations can be evaluated using scores. And what are scores? So basically, as I told you, right? So when we are measuring, after measuring, can you evaluate the output, right? So if you want to evaluate such outputs, something called as a scoring mechanism comes up, and in Langfuse it's pretty tightly coupled to the trace, because every trace that you get is an interaction with an LLM, right? So you definitely might be interested in knowing that, hey, the output that I got, is it relevant enough for me? Like, does it have toxicity? Is it hallucinating? Is it relevant to the question I asked? Is it clear? Is it concise? It can be anything. Like you can determine your metrics of how you need the answer to come out, and then you can tie it to the scoring object, so that whenever the traces are getting generated, you have scores also coming in. So if you see here, Langfuse is a very interesting way to do it. So it's something called as scoring, and the score object is tightly coupled to the trace object and trace to the observation. And if you see, there's another line which goes from the score to the observation, right, which says that that's an optional reference observation within a trace, right? So uh, you can score the observations also. So that way we will see actually in some examples going forward. And yeah, and just covering the types of scores. So there are different types of scores, because it can be like linguistic, it can be mathematical. Really, you're looking at more accuracy. So that's why you're numerical, you have categorical, you have association with trace, you are linked to a specific observation. So there are multiple ways how these metrics can be calculated. I'll take a pause. So any questions we have till now before I jump into a demo now? Like demo number one. Cool. Just stop me in case like things are getting quicker or you need a briefer explanation. Please do let me know. Okay. And in the call, can people, because I see a fair representation of folks, so could you tell me like how many folks are really from the technical background and not from the technical background, so that I can tune this conversation that way? So that would be helpful. Just in the ping also, it's fine. Like we don't have to speak out. So that's okay. Let's go to demo number one. Okay, so so before that, you know what? Let's look at Langfuse. Okay, so basically this is the portal. So this is the tool on Langfuse, and the ways that you come here, you create a project. So I just created a project, right? And then inside the project, once the application starts making those calls which you are tracking, you would eventually see those entries coming up here as records. But we would see that happening, right? And then there are other features also which we would see. But this is eventually the portal where the application is connected to at the moment, where we can see the traces coming in. Okay, so what I'll do here is, so I'm currently running a Python file, and so I just ran the file, and you see just two output coming, and I'll let's look at the output first, and then I'll take you to the code and basically what it does and how it happened. So you see the question, the query was really who is the first president of India, like, okay, and the question and the answer is from the Google searches that the first president was Dr. Rajendra Prasad. He held the office from so and so. The answer from LLM knowledge. So LLM knowledge meaning that the knowledge of the LLM. So there's no outbound call. You're just asking the Gemini. So here I've used the Gemini models to ask my questions. And as you know, the LLMs have maybe a cutoff date of information. It has general information, but not all the information, right? So that's why you have to rely on other knowledge sources, right, to enrich your data. So so looking into that here, so basically what we did is uh, I have created a client here, right? This is the model that we are using, Gemini 2.0. I'll just skip you to the important parts. This is the LLM knowledge, right? This is the model we are using, and this is the answer from the LLM knowledge, right, that we saw, and we're calling it here. So basically, we have a query here, like who is the president of India, and what we do is that we are calling the answer, right, from here, and we're returning the LLM knowledge. But there is another function also you see here called as Google search. So what we do here, that we take the same question and we call Google, right, to get the answer from it, and we are returning. I will cover all these things also in details, but as of now, that's that a very simple thing that is happening. And you know what, now that we are here, we can change it because both answers were same. So maybe I can ask, who was the most recent winner of of the FIDE chess championship, right? So this one happened, I believe, last year, December, or this year, maybe January, something like that, when Gukesh won, right, the World Chess Championship. And if you see the answers now you see the first one is from the Google search, so it has the up-to-date knowledge, right? But if you see the LLM's knowledge, definitely it's giving you Ding Liren from China, who was the previous winner, right? The reason just I did to show that there can be changes in answers based on how current question that we are calling, right? Now that we see here, so we called it twice, right? So you saw two entries coming up here, right? One 1617, one 1619. Let's just look at the most recent one here. And if you open the trace, so basically what you saw is that okay, you have a main function, good, and you first called Google search, and then you called LLM knowledge. So that is exactly what you see here. So the question was, who was the most recent winner of the FIDE championship, and this is the final answer, right? Like, so the main, it gave that it's Ding Liren, right? That's what we were returning from the LLM knowledge. But if you see Google's knowledge, so it's Gukesh here, right? And the same here, like, so this one shows here. And what does this tell you here is you actually see all these traces in this format. So it will show you that hey, this was the main function that first was called, then this was called, and then this was called. So it shows you in a very nice manner, in a timeline kind of manner, so that you know that hey, what happened, who called whom, and what things have happened here, right? uh, the things that I skipped there here is that I these are some input costs which I've assumed the tokens would be. So not only can you see the traces, but you can even calculate the usage of how much per call a model will cost, right? So if you have certain LLMs, so I think most of the LLMs it supports via tokenizer out of the box, Langfuse supports. But in case your model does not support, so this is a smart way where you can directly add those informations in your responses, right, whenever you're getting the answer. And that's where you see the input number of tokens, output number of tokens, and what's the cost for each call, right? And that's what we see here. So if you see here, right, it says that hey, 3826 is input, 80 is output, total 106 tokens, total cost $1.76, latency, and this. So this becomes a very vital information whenever you are trying to build systems, right? Like maybe they're taking time, maybe they're taking more cost, maybe the output is not good, but it is taking more time or more cost, and maybe you want to optimize there. So like this is the advantage of observability, where these metrics are very open for you to interpret, to see, right, and then take a call. I'll wait here. Any questions we have here, or anything we're following, not following, or you want to slow me down? I'll take that as a no then. So yeah, so basically we saw the demo, right? So after building block 3 we saw the demo, right? Then the next part, which is very important. So once we started getting traces, right? Basically now you're recording the calls. So next thing is evaluations, and evaluation is one of the most hot topics and important things for LLM. Reason being is because LLMs, as I told you, are stochastic, they're non-deterministic. You ask the same question maybe 10 times and you might get a more or less similar answer, but you might not get the exact answer, right? And when you're building software systems, uh, sometimes consistency is needed to build systems. Like suppose you are creating an employee class, right? Or you are creating a department class, a department object. Department has list of teachers inside it and all these informations, and you always want that information to be hydrated with those information, right? And not by any strict comment. Like sometimes you ask, hey, was the first president uh, of India? So it will say the president is this, or sometimes it starts with directly the name. So there can be variations, right? Because that's the nature of LLM. As much as it helps us, that's the way it interacts with. So evaluations, that's why become very fundamental, and Langfuse has ability to do that as well, where you can evaluate a particular call based on some ground truth, which we say. So ground truth is like if you know the answer beforehand, you kind of compare with that. But sometimes you do not have the answer beforehand, then you compare against different metrics. Like you check what answer came in and what was the question. Is it relevant? So we sometimes call it context relevance, right? Or you have the chunks of information from which the answer was made, and then you say, hey, the answer was not made nicely, it probably left out some other chunks. So that's so there are multiple metrics. I think there is a very good library called Ragas, something where they do a lot of evaluation frameworks. But Langfuse too does it, and Langfuse also can get has integration with Raga, so you can push all your evaluation data into this pipeline so that everything is in one place, right? So this slide is a text heavy slide, intentionally kept. So the evaluation pieces are that it does a model based evaluation. So model based evaluation is nothing but just using another LLM and saying, hey, you can you evaluate that for me, right? So you say that, hey, these are my answers, these are the questions, do you think it's correct or not? Because LLMs have general knowledge, right? So you would think that maybe they can do a good job around there, so that's why you use that. Second, what Langfuse gives is manual annotation. So you can go to the traces and you can kind of tag certain places that, hey, this answer is incorrect, maybe this should have been this, right? Because when you go for human evaluation, you want these informations to be captured. So that is also there. User feedback is also another way, a similar way where you add comments and all there. And another is custom evaluation by SDKs, APIs, and this is where you have these multiple. So everything in Langfuse has an API and SDK. So whatever you see on the screen, you can use APIs to push data back into the Langfuse, right? So you use probably Ragas or some other evaluation framework, but you want to collect here, so you could push all that data and get it here. The next topic is model usage and tracking cost. What I told that you can see how many tokens are going. So model usage was that where we saw that how many tokens are getting used, because tokens are really kind of the currency on how they get measured, the costing gets measured. And then you can track costs, that you can see how it does. And you have custom ways, as I told you, that if you are using a custom model, you have deployed it yourself, and you want to score it, or you want to cost calculate it yourself, then you can write custom code and plug it back into the Langfuse pipeline, where it will keep on calculating for every call it does, right? So here, just going back to the first demo, I will try to pull something here. So let's go to scores, okay? And if you see this question, so you remember the trace that we used, right? Like who was the most recent winner of this one, right? And what we are doing is we are kind of like calculating or evaluating that answer, right? So if you see the ground truth, so basically what I did is the Google search that was doing, right, I pushed it as a ground truth here, right? And the one coming from the LLM was evaluated against it. So if you see that there is a change here, right? So the expected data should be the current data, but the LLM didn't have that knowledge, so it gave this data. So that way you can actually go here, right? And if we can open this, yeah. So here basically you can see, so it calculated a score here, and you can see the score is like 0.200, right? And it has a comment also added here, so it says the generation income states that Ding11 is the most recent winner, right, while the ground truth indicates Gukesh was the winner. So the generation is outdated and does not align with the ground truth, and hence they are rating it lower. This is LLM as a judge, so we are using Gemini model here to evaluate the answers themselves, because here we have a ground truth. So that's how evaluation also can be done. So it's very easy to do that here as well. And let's look at demo number 2. Okay, so there is a feature in LLM called as function calling. So what happens is basically LLM might not have all the information, so what you do is you augment your LLM and you give them capabilities to go and do certain things and come back and reason with LLM and then proceed till your goal is met, right? So that's how you really get the best of the worlds. You get LLM as a brain which can do good reasoning and take action, but your uh, execution and command, someone else is doing. The LLM does not do that. So this code that I have now, the second piece is that, and basically what it does is it is a natural language to an SQL query, right? That is what it does. So we have a database, we have a Postgres database here running, right? The name of the database is DVD rentals, and it has probably uh, maybe just a second, yeah. So it has roughly 13 14 tables probably inside it, like actor, address, category. So it's about collection of information of all the people who go to DVD rental store and rent DVDs. I know, pretty old example these days, who goes to DVDs, right? And all is Netflix, but yeah, that's just how the data has been picked up here. And basically it's people who pay and take the DVD, rent it out, and then give it back, right? So this is the entire data set that it talks to and what it does. And what we kind of do here is, with that other code, is so rather than writing stored procedures or those ways, right, traditional ways to get data out from LLM, can we kind of give a text box, and can the LLM talk to the database or help us talk to the database and get us the results that way, right? So basically this code, if you see, I've just hooked up to my local Postgres DVD rental database, right? And I created a React agent. So React agent is nothing but a reasoning and an action agent, basically like a basic bare minimum agent which they do, right? And I have given a tool list. So this tool list is from Llama Index. I'm using Llama Index as one library for data orchestration, and it has something called as a database tool spec, where it says that, hey, if you give me your database details, I have certain abstraction, and I can help you talk to the database, right? And this is exactly why we need LLM orchestration, LLM observability, because we don't know what is happening under the code. Like, this is what the code basically is, right? And really nothing kind of makes sense when you see here, in terms like it's not quite visible that way. And now when I type this query, right, and I say uh, who was the customer with the highest bill for DVD rentals, like, this is a pure natural language question, right? And I'll just move this a little bit up. Hmm. So the one in the pink and the blue and all these things, right? So is what you can see is it starts here. So there were some errors also along the way. So that's interesting to see. But let me try to clear the screen and run it once more. Okay, so this is the input that we are giving. So like who was the highest DVD rental that happened. And if you see here, the way it approaches is your database has a list of tables. So first it picks up the tables list, right? Then from the table it tries to reason out, okay, the person needs to get the highest DVD rental cost and how much. That means maybe it's to do with customer, maybe it's to do with payment, maybe it's to do with cost, right? And then what it does is it picks up those specific tables. If you see here, customer, rental, payment, right? And then what it does is, after taking those three tables, it kind of also looks at the columns inside the table to reason out that, hey, can I write an SQL query which can do that, right? And eventually it ends up writing this SQL query, right? So it comes ahead and it says that, hey, I right, it comes here and it writes an SQL query here. And if you see, it comes as Eleanor Hunt with 211 rupees. Well, basically, if you see the query, right, so it picks up the first name, last name, and the total sum, right, from the customer object, then does an inner join based on that relationship, because it has access to the schemas and the relationships between the table, because that's what that tool spec did. And then eventually it does a group by and figures out, okay, which is the most highest one, and then does a descending and does that thing. But the interesting part here is to look at the traces, right? So if you go at the trace here, so this is exactly how a trace looks at, right? So if you see, there is so much happening around here, right? Because what happened when we ran this is that your LLM talks to the database. Like, the LLM never directly communicates to the database. LLM will always depend on the tool to execute. So it gives the tool the command that, hey, you take this command. Like, for example, this was how it started here. If we see who was the highest, right? This was the question that we asked, and it went here maybe. Okay, and probably in the next step, if you see, it first fetches out all the table names, right? Then because it has three functions called as list of tables, so it says, hey, in order to solve this, I first need all the table information. Once all the table information is got, then it says, hey, you know what, now that I have the table and I know probably which table this has, can I get the columns that this has? So that's why it gets the entire table structure from here, right? So like it's digging deeper step by step. And last, when it has that, it says, okay, now that I have all this information, I think I should be able to write a query, right? And then it eventually comes here, like there's a lot of two flow happening, and it keeps on happening, like maybe two or three or four times it happens, and eventually figures out that, hey, then it executed this. So all whatever you're seeing here, the queries that are coming up, the LLM gives it to the Python code that I'm running. That gives it to the tool. The tool executes. Again, that response is sent back to the LLM. So that's why this entire chat history, or the thread that you see here, is this entire communication that happens there, right? So this is exactly why you are saying that we need observability, because you now absolutely are sure that when such libraries we are using, right, in LLM or using these Gen AI responses, you don't know what is happening under the hood, right? If you currently see here, so suppose let's look at this, right? Or let's, you know what, let's look at something more interesting. Hmm, here. Okay, so if you see this here, it says you are designed to help with a variety of tasks, from answering questions for providing summaries, um, to other types of analysis tools. You have variety of tools. So you see, this is a prompt. That means the tool spec that we use, database tool spec, someone wrote a prompt inside the tool to behave in a certain way, right? And these eventually determine how you are getting the answer or not getting the answer. And because of everything is transparent here, you kind of very easy to understand and detect. And what you do is you put evaluations on top of it, right? And you say that, hey, if this is happening, this should be the answer, or it should be context relevant, or this. And then basically what you do is, in the evaluation, you go and you see that, hey, after so many, maybe 100 or 200 traces that I ran, how many are falling in a good category and where I need to fix. So that is a more better way to fix things than just objectively looking at a single request and saying, hey, I'm not getting the answer, right? So that's how I think that this really helps us understand how we can write code and fix it, right? So that was here. Like, I'll just take a pause. Any questions or anything that you have, you want to ask or discuss?
Hi, Ansuman. I think we only have last 20 minutes with us, and there are two, three questions I can see in the chat box. Maybe
Oh,
we can start off with them.
sure. I'm sorry, I didn't see the chat box.
No problem. It's by Preeti.
Okay,
Preeti, do you want to come on?
yeah, please.
Hi, Ansuman. Thank you for the lovely session. The first question is regarding the cost that was listed for the trace. It was around dollar 1.78, but that seems to be too high for
Yeah,
one question.
yeah, correct. I think the initial ones were costed at $1. So I put in 0.35 or 0.035 as I put in my own costing here in the code when I was showing you. If I go here and maybe pull.
Okay, understood.
Okay, so I've assumed here to be 0.35 USD dollars per token cost. I don't think this is the real value. It is purely 0.00 something that way, right? So, but the actual cost will be down. The reason I did is I'm using Gemini. I don't have an Open AI account. Like if you use Open AI, you don't even have to do this setup. They directly read from the tokenizer and give you the answer. So I haven't done a benchmark on what is the costing and all, but one thing I've seen that whenever you use natural language to SQL, the time will be more, right? Because you are no longer using a stored procedure, so which is finite, right? Which knows exactly what to call and how to call. But the convenience it gives to the user is how you want to ask the question. So yeah, and definitely costing is the part there which we have to kind of regulate.
And second question is across around evaluation. How do we compare the LLM results across multiple sessions?
Yeah, I think what you can do is Langfuse has this feature called as experiments. Okay, so you can go to evaluation here. Let me show you that. Okay, and so basically you can pick up a template. I haven't done that here. So basically what it says that what you can do is you can create data sets, right? And you can run evaluations for the set of data, right? And then see the results. So probably you have written the same functionality using two different models, right? And you probably want to see which one is a better, or in which areas one model is better and the other one is better. So you kind of do that. You package it and you send it to the like you send it to Langfuse to put it here. So the evaluation happens here, or you can use any third party evaluator and you can view your results here. But that is doable.
Thank you.
What were the other questions? Do we have any other questions, or shall we?
No, Ansuman. I believe those were two asked by Preeti. Is anybody else here have any questions?
Okay. What was the next one? So we just move because I think the next ones are pretty small. So the pricing and the docs, so these are really important things. Let me show you here. So it has so much information that it's not possible to put it in a single slider, right? So I just wanted to see the pricing model. So yeah, so looking at Langfuse pricing model, so Langfuse has quite different ways of how you want to use it, right? So one is the cloud one that I currently am using, that I showed you, right, on the hobby tier. And then it has core, pro, enterprise, and then you can see all the features coming in here, right? You can also see that what all features come with what all plans, right? For example, like user tracking, and then the number of events. If you see, the volume also increases, right? Because you'll have huge data. Another thing which is important that I saw here is that like LLM evaluation, LLM as a judge and all, those are specific to their cloud variant, right? But at the same time, they have self-hosted also, because it's fully open source, so you can take their code and deploy it onto your instance. But if you see, you probably might miss out on some of the paid features of the self-hosting as well. Like they still have another tier called as Pure and Enterprise, but in open source you can kind of uh, like you can use the GUI of Llama Cloud, you can deploy and you can do support, and you can see, like, you can do traces, you can do user tracking, you can do telemetry, proxy based, blah blah blah, prompt management. So they have a way. So if you see, prompt management is there but it's not listed, but they have, you can store your prompts there, you can do versioning of prompts as well. So all those are also available here. Mostly the open source has most of the things, but yeah, you might be missing out on some other features and how to use it. So I will leave up to you that on what kind of business or what kind of company you want to adopt the features. But the base tracing, and maybe you pick up tracing, right? So like, how would I suggest is, maybe you pick up tracing because Langfuse is good at tracing, but maybe the evaluation features are not there. So you pick up Ragas, which is another open source. You do well evaluations with this and you push it into Langfuse, right? If you're looking at cost reduction. But if you think that yeah, you're good to go and you want everything at one place, yeah, you can definitely go and use this as well. This is the pricing thing. And I think the other one was the references. The references were taken from Langfuse docs. So this is just nothing special about that. And what else I had? I think yeah, I think we're done. Like we have like some Q&A if we still have, if we want to cover, or else we can close it early. And I like just wanted to understand that whether this was too technical from your side or whether you're looking at something on a generic LLM. The reason I picked up this topic is yeah, we are all talking about LLMs, and that's important because it's giving us value. But the other piece which also has to be talked about is how we're going to observe them and how we're going to evaluate them, because evaluation is a must when we're going for LLMs, because that eventually determines whether you'll use that product or whether it's valuable for you or not to build systems. So that's just a takeaway.
Cool. Is does anybody here have any questions? Okay, I think Ansuman, then we can close early. Just a quick note, guys. This webinar will also be available on Sedin's YouTube channel, and we'll be sending out a feedback form about the webinar. Just to get a quick update on how do you guys liked it, what improvements we can do. Do check out your emails. And
Yeah,
thank you so much, Ansuman.
yeah, I think we got a question. What are the alternatives for Langfuse? Alternatives for Langfuse are Langsmith, Opaque, Helicon, Arise by Phoenix. So there were multiple. It's not that Langfuse only does this. All the ones that I spoke, they do all, mostly all do the same thing. Like they track traces, they evaluate, and they help you take a better decisions. So yeah, definitely try the others and figure out if those are more tailor made for your use cases. Uh, yeah, I think that's it.
Perfect.
Okay. Thank you so much, team. Thank you.
Thank
Bye.
you all.